Hello, good morning, students. I hope you are good and safe at home. In class 10th, up to now, we have discussed how to balance a chemical equation. Now, in today's lecture, we will discuss the types of chemical reaction. So, during a chemical reaction, atoms of one element do not change into those of another elements, nor do atoms disappear from the mixture or appear from elsewhere. So actually, the chemical reactions that involve the breaking and making of new bonds, or the breaking of old bonds and making of new bonds between atoms to produce the new substances. So mainly there are four types of your chemical reactions. One is combination reaction, second one is decomposition reaction, then third one single displacement reaction, and the fourth one is double displacement reactions. So first of all, let me discuss your combination reactions. Combination means, as the name mentioned here, combine, meaning by combining something. So combination reaction means a reaction in which a single product is formed from two or more reactants. You have more than one reactant and the single product is formed. So that single product which is formed from more than two reactants, that type of reactions are known as combination reaction. For example, your calcium oxide reacts vigorously with water to produce the slacked line. Calcium oxide is this CaO. So calcium oxide, this one calcium oxide, that react with water H2O will give calcium hydroxide, which is also known as slacked lime. Calcium oxide is known as quicklime. Got the difference? Calcium oxide, quicklime, and calcium hydroxide is known as slacked lime. So when calcium oxide and H2O, now two reactants are there. One is your calcium oxide, another one is H2O, water. So calcium oxide and water molecules that combine to form a single product. Now see, there are two reactants here. One is calcium oxide, another one is H2O. So we will get a single product here, that is calcium hydroxide. So this is an example of combination reaction. Similarly, you can see here your sodium and chlorine will give NaCl. Now Na here, that is sodium plus chlorine, Cl2. One Na with Cl will give NaCl, another one Na with Cl will give NaCl. So that's why your sodium with chlorine, another one reactant, that will give NaCl. That is a single product, that is NaCl. When we write its equations, it will become, even if we want to write out one molecule of your NaCl, so it is half of Na plus Cl, that is Na plus half of Cl2, that will give NaCl here. So therefore, in this case, in the types of your chemical reaction in which any two reactants A plus B will give a single product, two reactant combine will give the single product. Examples of combination reaction, other examples of combination reaction, let me see here. Photosynthesis, you know very well. Carbon dioxide plus H2O, that will give glucose plus oxygen. When we balance it, you know very well it is not balanced. When we balance it, it will get 6CO2 plus 6H2O will give C6H12O6, which is known as glucose, and oxygen, 6 molecules of oxygen. So here we'll get carbon dioxide plus, right, H2O will give, product is your glucose, and so carbon dioxide and water that will combine will give to the formation of your glucose. Another one example, that is your formation of water. H2 plus O2 will give H2O. So that is also the example of your combination reaction. Similarly, in another one example, formation of salt, sodium chloride from Na, and that is Na means sodium and fluorine will give NaCl. So therefore, in general form, A plus B will combine, will give C. That is the major product as C. After that, this thing is also given in your book. A solution of slacked lime produced by the reaction, which is also given in NCERT book, that is 1.13, that is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. So it is interesting to note that the chemical formula for the marble is also calcium carbonate. For the marble it is also calcium carbonate. For chalk it is also calcium carbonate. So calcium hydroxide plus carbon dioxide will give calcium carbonate plus H2O. Let us discuss some more examples of combination reactions. Let me see the burning of coal. When the coal has been burned, that because that is burned in the presence of oxygen, that will give the formation of carbon dioxide. This one. Similarly, the formation of water from H2 and O2, hydrogen and oxygen gas. So in simple language, we can see here now H2, your hydrogen gas plus oxygen, that will give the formation of H2O, that is water. So in simple language, we can say that when two or more substances means that can be elements or that can be compounds that combine to form a single product, and the reactions are called combination reactions. Now, in the combination reactions, as we have seen that in some reactions the heat is released along with the formation of products. For example, the burning of a natural gas. Now, in this case, you can see in the burning of the natural gas means, let me take on natural gas, methane is one of the part of your natural gas there. So this one is methane, CH4, that is methane. So methane plus oxygen, that will give carbon dioxide plus water. So in this reaction, now here the methane and oxygen are combining. That's why they are known as one of the example of your combination reaction. Now see here, in this reaction the heat energy has been released. Now heat, for example, in your home, when you burn the stove or your gas chula, so you can see here the heat energy has been used, which is used for the cooking of food. So reactions in which the heat is released along with the formation of products. So along with the formation of products, if the heat energy is released, that type of reactions are known as exothermic chemical reactions. Exothermic chemical reaction, for example, burning of natural gas. Clear to you all? Now, do you know that the respiration is also an exothermic process? We all respire. We need energy to stay alive. We get this energy from the food we eat. So during the digestion, your food is broken down into simpler substances. For example, rice, potatoes, bread, that contain carbohydrates. So these carbohydrates are broken down to form glucose. So this glucose that combine, this is your glucose C6H12O6. This glucose combine with oxygen. Oxygen means O2. With oxygen uh, in the cells of our body and provide energy along with carbon dioxide and water. So therefore we can say that our respiration is also an exothermic process, because energy has been released and this energy is used for various processes. For example, the energy which we will consume, that is utilized for the we will talk for, that is for talking, walking, for the concentration, to study, for each and everything, from each and everything any human beings that will do. So the energy is required. So it means this respiration, that is also an exothermic process. The second example is the decomposition of vegetable matters into the compost. Whatever the vegetable matter is there, when you may have seen, when you put your this kitchen waste, the into the pit, so it after some times, or after 1-2 days, you will see that it becomes little bit hot, or the temperature has been raised. So reason being, because that is also an example of your exothermic process. So therefore, whatever be your vegetable waste, or it may be your respiration, so these all are the examples of your exothermic reactions. Clear to you all? So second type of reactions, that are decomposition reactions. Decompositions. So as the name mentioned here, decompose. So the reactions in which a single reactant is break down to give simpler product. A single reactant, that is A will give A, on the breakdown of that will give B and C. So that type of reactions are known as decomposition reaction. For example, we'll take the examples of your ferrous sulfate. So in the examples of ferrous sulfate, you can see here, now this ferrous sulfate have the chemical formula FeSO4. So ferrous sulfate in the presence of heat. Heat means when we heat it with the help of burner, let me take a ferrous sulfate in the test tube, then we heat it in the presence of heat it and with the help of burner in a test tube or in a beaker. So what we'll got? We'll got Fe2O3. Fe2O3 is known as ferric oxide. This one, ferric oxide, plus sulfur dioxide gas and sulfur trioxide gas. Of the sulfur dioxide and sulfur trioxide, these are gases, so they will be escaped to the environment. So therefore, now here in this case, a single reactant, which is your ferrous sulfate, that will change into more than one product: ferric oxide, sulfur dioxide, sulfur trioxide, in the presence of heat. So that's why this is an example of decomposition reaction. Decomposition is there, meaning by A, any substance A, that will give on breakdown to B, C and D. Let me take another one examples of decomposition reaction. Let me see the case of your hydrogen peroxide. Your hydrogen peroxide, that will give H2O and O2. H2O means water, and O2, hydrogen peroxide, have the chemical formula H2O2. So one single reactant will decompose to H2O, that is water, and oxygen. So that's why it is an example of decomposition reaction. Let me balance it. So then another example, we'll take the electrolysis of water. Electrolysis of water means the decomposition of water in the presence of electricity. When we apply the electricity, this diagram is also given in your NCERT book, that is the electrolysis of water. So when H2O is electrolyzed, meaning by when the electricity is passed through water through your two anode, which are known as anode and cathode, so then what will happen? The two gases will be collected. One is at anode, another one is at cathode. That two gases are H2, that is hydrogen gas, this one, and another one is your oxygen gas. So now we balance it. 2H2 will give H2 plus 2O2. So here also your one molecule of water will decompose to hydrogen and oxygen. That's why it is an example of also decomposition reaction. Another example, similarly, the decomposition of nitrogen triiodide. Nitrogen triiodide means NiO3. That will give nitrogen gas and I2, that is iodine. So this is an example of decomposition reactions. This one, that we balance it. So it is multiplied by 2 and iodine is multiplied by 3. So therefore in general form we can say that your decomposition reaction, for example, you have a substance having chemical formula AB, if there is single reactant is there, that will decompose into A and B. There is more than one component is there, maybe 2 component, 3 component, 4 component, meaning by single reactant that will decompose into more than one products. So that type of reactions are known as decomposition reaction. So as I already stated to you, the decomposition, for example, in this case, in that case of ferrous sulfate, we decompose the ferrous sulfate in the presence of heat. Similarly, we decompose the H2O, that is water, in the presence of electricity. Similarly here, the decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction that is used in various industries. Calcium oxide is called lime or quicklime, and it has many uses. There are so many uses of calcium oxides are there. One, in the manufacturing of cement. Cement we are using at home for various purposes. This calcium oxide is one of the ingredient for the manufacturing of cement. So when decomposition reaction is carried out, now see here in this case also the calcium carbonate, which is a single reactant, that will decompose into calcium oxide and carbon dioxide. So now in this case, because a single reactant decompose into more than one reactant, that's why it's an example of decomposition reaction. And now you see here in this case the reaction is carried out in the presence of heat. So that's why this type of reaction is known as thermal decomposition reaction, meaning by the reaction which is carried out in the presence of heat. Heat means thermal means heat. In the presence of heat, that type of reaction is known as thermal decomposition. Other examples that we take of your decomposition reactions, your heating of lead nitrate, as we took the example of ferrous sulfate. Similarly, the lead nitrate have the formula PbNO3 twice. In the presence of heat again, that will give PbO, that is this one, lead oxide plus nitrogen gas plus oxygen gas. So here in this case also you can see that your lead nitrate decompose in the presence of heat. So that's why this is also the example of your thermal decomposition reaction. Let us perform some more decomposition reaction. Now here in this case you can see here, this is the electrolysis of water, and this is the we'll take the silver chloride in a china dish and put in the presence of sunlight. First case in the first case we did the electrolysis of water here, meaning by this is your 6-volt battery here. Now these are anode and cathode, and therefore when we apply the electricity through this battery, so electrolysis, meaning by in the presence of electricity, this water decompose into H2 and O2. Hydrogen gas will be collected over here in the cathode, and oxygen gas will be collected here in the anode. One more important observation you can see here, the volume in this case of your oxygen gas, that is double than that of the hydrogen, and then that of the oxygen gas, that is the hydrogen gas which is collected over here. The volume is double. Reason being, because by the decomposition of H2O, we'll got H2 plus O2 in the form your 2H2. So that's why here the volume of your hydrogen gas is double. Now in the presence of sunlight, as it is written here, that is given here, the silver chloride. When we put silver chloride in a china dish, then in the presence of sunlight, what will happen? This will change into Ag, that is silver and chlorine gas. This one, silver and chlorine gas. So reason being, because it also decomposed. The decomposition is there. Why? Because silver chloride that will decompose in the presence of sunlight will give to the formation of silver and chlorine. So this is the due to the decomposition of silver chloride into silver and chloride by the light. Another example, we can take silver bromide. In the same way, that will give to the formation of silver and bromine gas. So these above reactions that are also used in black and white photography. Initially when we had a black and white photography, then these reactions were used for that. So we have seen that the decomposition reactions. Now decomposition reactions are mainly carried out by three way. Which three way? One is your by heat, second one is by light, and third one is by electrolysis. In the electrolysis or heat or sunlight, we took the various example. In the case of your heat, we took the example of your ferrous sulfate. In the cases of your decomposition by electrolysis, we took the example of your water, and in the case of your sunlight, we took the examples of silver bromide and silver chloride. Got it? So it means the decomposition reaction require energy. Now that energy, that may be in the form of heat, or that may be in the form of light, or that may be in the form of electricity. That may be in the form of heat, light, or electricity. Heat, light, or electricity for breaking down the reactants. So reaction in which energy is absorbed, they are known as endothermic reaction. So in these all type of decomposition reaction, whether they are in the presence of heat, whether they are in the presence of light, or whether they are in the presence of electricity, the energy is absorbed. The energy is absorbed. That's why they are known as endothermic reaction. So therefore, up to now we discussed about your exothermic reaction and endothermic reactions. Exothermic reactions, the reactions in which energy is released, and endothermic reactions, the reactions in which energy is absorbed. So therefore, in today's lecture, we studied about the two types of your chemical reaction. One is your combination reaction, another one is decomposition reaction. Combination reaction means any two or more reactants combine to give a single product. Decomposition reaction is the reverse of that. That is one reactant that will decompose either in the presence of heat energy, or in the presence of light energy, or in the presence of electricity, will give two or more products. Clear about this thing? Now, on the basis of that, let me discuss your in-text questions, which is given in your NCERT book. Uh, a solution of the substance X is used for the whitewashing. Name the substance X and write its formula. So now a solution of substance X is used for whitewashing. Immediately it should become to your mind the whitewashing. For whitewashing we will use calcium carbonate, chuna, right? That is known as calcium carbonate. Now whitewashing means calcium carbonate is there. Now from which the calcium carbonate is formed? That is your slacked lime, calcium oxide. So therefore the substance X is your calcium oxide, because calcium oxide that is used when it is dissolved in water, it will become calcium hydroxide, and then this calcium hydroxide that is used for whitewashing, it will absorb the carbon dioxide from atmosphere, and after some time or next day it become white because of the formation of your calcium carbonate. So therefore the substance X is your calcium oxide, and the chemical formula for that is CaO. Calcium oxide reacts vigorously with water to form calcium hydroxide, which is named as slacked lime. Calcium oxide, quicklime, and calcium hydroxide, slacked lime. This one. And this slacked lime, calcium hydroxide, that reacts with carbon dioxide from atmosphere, absorb carbon dioxide from atmosphere, and that will give calcium carbonate, which is white. Second question is, why is the amount of gas collected in one of the test tube in activity? Activity means, or activity 1.7 means the electrolysis of water. So, and name that gas. So reason being, as we have already discussed, because water contains two parts, hydrogens, and one part oxygen, as also as per its chemical equation which we discussed. So therefore the amount of hydrogen and oxygen produced during the electrolysis of water is in 2:1 ratio. During electrolysis, since hydrogen gas goes to one test tube and oxygen goes to another test tube, so the amount of gas collected in one of the test tube is double of the amount of the other. Reason being, the ratio is there 2:1. Clear about this thing? So this is about your two types of your chemical reaction, that is combination reaction and decomposition reaction. Thank you very much for today's lecture. Be safe and be healthy. Thanks.